Hello everyone, and welcome to this video covering the syllabus for CSC 142, Computer Programming 1, at South Seattle College. I'm Dr. Charles Reed, the instructor for this course, and in this video I want to cover what this course is about, go through the important points of the syllabus so that you understand how this course is going to work, and set up some expectations that you can have from this course and that I'm going to have of you during the course. So let's talk about what this course is about. In this course we're going to review some basic programming skills that you obtained from CSC 100. It's also intended to prepare you for CSC 143, so this is the second in a sequence of 3 courses. In this course, we're going to focus on procedural programming. This is in contrast to object-oriented programming, which we talk about in CSC 143. Procedural programming means we're programming the way that we read a recipe. Things go from start to finish. Everything is procedural, meaning it works like a script or like a recipe. We'll get more into object-oriented programming in the next quarter. We'll touch on it a little bit at the end of this quarter, but it's really not the focus of our course. And this course really isn't just for computer scientists. It's also for people who are interested in engineering, or physics, or math, or chemistry, or any kind of applied science. Programming is a really useful skill to have generally, outside of computer science as well as within computer science. So taking this course doesn't necessarily mean you have to become a computer scientist. Some topics that we'll cover in this course include a basic introduction to the Java programming language, what makes it unique. We'll cover how primitive data works in Java, how we store variables, how we use loops. We'll talk about parameters, methods, and objects, which are a very important part of Java. And we'll talk about logic, execution, and controlling our programs. We're also going to cover 2 very important topics. One is file input and output, or file processing, and the other is arrays, which is a way of storing one-dimensional stacks of data. And we'll go into a little bit of object-oriented programming at the end of the course. So as I mentioned, I'm Dr. Charles Reed. You can call me Dr. Reed. And I'm a math and computer science instructor here at South Seattle College. My email address is listed here on the slide, as well as my office hours, my office location and office hours. So you can come find me during those office hours. You can also email me to set up appointments outside of those office hours if those are problematic. Okay, let's talk about the syllabus. So you should have the syllabus in front of you or open on the screen next to you as you're going through this video. The textbook that we're going to use in this course is listed as the 4th edition on the syllabus and the 3rd edition on the slide. That's mainly to indicate that either edition is going to be fine. I'll be providing you with homework questions so you won't have to worry about differing editions. The book is called Building Java Programs, a Back to Basics Approach, and the authors are Stuart Regis and Marty Stepp. One of the authors, Stuart Regis, is a computer science professor at the University of Washington, and this is the same book that they use at the university. I already mentioned some of the course material that we're going to cover. Those correspond to chapters, so we're essentially covering the first 8 chapters of the textbook. CSC 143 covers the second half of the book, or the latter 8 chapters. Your course grade is going to be determined by an equal weight of different activities throughout the quarter. So there'll be a 20% weight on 5 different activities: your homework assignments, your quizzes, your midterm A, midterm B, and your final project. So I'll get more into the final project in a moment, but that's going to be in place of a final exam. So the final project will be something that you work on for a longer period of time and submit at the end of the quarter. So there'll be a 20% weight on each of those different things, and your final grade is going to be determined based on the final percentage that'll be converted to a 4.0 scale according to the table on this slide. So that just gives you a sense of how your final grade is going to be computed. As we go through the course, all of your grades will be in Canvas, so at any given point you'll know where you stand in the course. My homework policy is that as long as your homework is completed and submitted on time, you'll receive 100% credit. And the reason for that is the homework assignments are intended for you and for you to learn and practice your skills. So accordingly, it's really up to you to be determining what you get out of your homework. And so I don't want to be punitive about which questions you get correct or which questions you struggle with. A lot of these questions just take some time to answer, and you'll know once you've answered it correctly based on your program output. Late homework is going to be worth 50%, and I will give you the caveat that that builds up quickly. So stay on top of those homeworks. That's an essential part of ending up with a grade that you're happy with. The template for our homework assignments will be to follow an example that I will give you, and I'll also provide you with a Microsoft Word template that you can use when you're putting together your homeworks. And those will be submitted through Canvas through their assignment functionality. You'll be able to attach Word documents or PDF documents and submit that as your homework. I also want to talk about quizzes. You're going to have about one quiz per chapter throughout the quarter. These are going to utilize the built-in quiz functionality in Canvas. So these will be multiple choice questions or fill-in-the-blank questions or written responses. And for each quiz, I'm going to be giving you a 3-day window to take that quiz toward the end of the week, opening on Wednesday and closing on Friday. And you'll have 2 attempts at least per quiz. As far as midterm exams go, there's going to be 2 midterm exams during the quarter. The first midterm exam will cover the first 4 chapters, and the second midterm will cover chapters 5 through 8, with an emphasis on 5 through 7. Okay, so those midterms are going to consist of 2 parts. Those will be 1-part questions, which will look a lot like the quizzes. Those will be multiple choice, fill in the blank, etc. And 1 portion that will be a Java coding portion, where you will be given a problem and you'll code up a solution within a given time frame, be it an hour or 75 minutes. And you'll submit a Java file at the end of that time frame. The 2 midterms are going to be open for several days, so those will both open on a Friday and close on a Tuesday. And the dates for midterm A are open February 3rd and close February 7th, and midterm B will open March 3rd and close March 7th. In place of a final exam, I'll be giving you a final project. And the intention of the final project is to give you a problem that's a little bit different from a traditional homework question. I want you to get sink your teeth into a real-world problem that is multifaceted and that involves some coding, some research, and some writing, and kind of combines some creative thinking with some of the learning that you achieve over the quarter. So I'm going to reveal some details about that final project during the quarter. But this is a project that you'll have several weeks to work on, and you'll be submitting a draft several weeks in advance of the final exam date. So that final project will be due during our normally scheduled final exam time, which is Monday, March 20th. Okay, so again, more details forthcoming. I'll be providing some topics, so keep your eyes out for those. And that covers our final exam portion. I do want to say a few words about cheating and academic dishonesty. Now, this is a coding class, and given the nature of programming and the availability of code, it is more of a gray area than something like English. It's not as clear what's allowed and what's plagiarism when it comes to code. So I want to be very clear and upfront about this, that I consider what I consider plagiarism in the context of computer science is if you turn in code that has work that you have not done and it has your name on it without any reference to where that original code came from, that is considered plagiarism. Just the same as using somebody else's words without citing them in an English paper would be considered plagiarism. Now, that being said, it's not difficult to avoid any potential issues by just copying and pasting a URL in a comment or including a link somewhere in your final project or your homework or final project or worksheet write-ups. As long as you are referencing the original source of the ideas if they are not your ideas. This is a college class, so really it's about learning independent thinking and having your own thoughts. So make sure you give due credit to any thoughts or ideas that are not your own and that you are building on them accordingly. Okay, and my zero tolerance is if there's any kind of plagiarism going on, I will be assigning zeros for any assignments involved in that. But I know that you're all adults and that this won't be an issue, so I don't think we'll have to address this again. Okay, I want to mention some resources on the South Seattle campus that you can take advantage of. The first is a tutor named Chase. Chase is available at the Anna Peasy Center. This is in the library of the South Seattle campus in room 215, so this is on the second floor of the library. And Chase has sent out, or the Anna Peasy Center has sent out hours that Chase will be available. So he's listed as being available on Fridays from 10 a.m. to 2 p.m. So if you want to get some help or some tutoring, if you have questions in general about the lecture material or about worksheet or homework assignments in particular, you can bring those to Chase. In general, if you have just general tutoring needs in math or science, these aren't always going to be good places to go for computer science tutoring specifically, but they're good to know about. The first is the mall, so this is also located in the library, second floor, room 215, and this is drop-in math and occasionally computer science tutoring. There's also the MAST, which is a tutoring center near the registration office. This is drop-in math and science tutoring, and they have some pretty extensive hours. They're open in the evenings and on the weekends, so that's a great place to go if you just need a place to study or to get some help. And if you have a group and you just need a location to study, the Robert Smith Building, room 12, has a tutoring center where there's some space for individuals and groups to have some tutoring. Now, I also want to mention that South Seattle is very accommodating of any students who have special concerns or needs. So if you need any accommodations, please get in touch with me right away and let me know what you need. Canvas is very accommodating of these kinds of things, as is the administration and as am I. So please just get in touch. Disability Services is also there to help you to get any kind of paperwork verified that you need, and help you out with that. Now I want to close by giving you a quote to think about, and this is something that is very pertinent in computer science. And the quote is, "For every complicated problem, there's a solution that is short, simple, and wrong." Now this can be extrapolated to apply to computer science generally. If you think that you've found a short and simple way to pass the course without doing all of the heavy lifting and doing all of the work involved, then it is the wrong course. So in order to succeed in this course, you need to know first what your overarching goal is, why you're in this course, why you're learning programming. And this is because programming is becoming an important skill for everybody to have in any kind of discipline. And in order to succeed in programming, not only do you have to have the larger goal in mind, but you have to put in the work. That means doing your homework, putting in the time. Just as swimmers do laps, just as musicians do scales, programmers write code. There's no other way to learn how to code except by practice. So homework is a critical part of building those coding muscles, and I encourage you to take advantage of resources like Practice It and the textbook website. And I encourage you to put the time in, because an hour up front will save you 10 hours later in the quarter, because each concept will build on the next. And I promise you that if you put in the extra time, you will be amazed at the results. Being a programmer is not something that is innate to anybody. It's really just a matter of how dedicated to your end goal you are and how much time you put in. So if you put in the adequate amount of time, you'll do great and you'll be a great programmer. So I look forward to interacting with you during the rest of the course. You can be on the lookout for Homework 1 and Worksheet 1 to be posted, and I'll also post some lecture materials related to Chapter 1. As far as next steps for you, I would encourage you to download the Java Developers Kit. I will post a YouTube video that will cover a little bit more of the details of that from Barbara Heck, I believe her name is, Barbara Hecker, or Heckler. I've already posted a link to that in the announcements, so I'd encourage you to check that out, download the Java JDK, and get started with Java. We'll see you in the course.